purpose of this video is to go over question number 9 in the 3.5 homework. And we're looking for the values in this trigonometric function that have a horizontal tangent line. And if we look at a trigonometric function, it's going to be sinusoidal. So we're going to have this wave, and you can see where the first derivative equals 0 is going to be possible horizontal tangent lines. So our answers are going to be unlimited amount here. Since we're not given a domain to focus on, we're going to have to come up with our answers as a formula. So to view the example in my math lab, here they go through and they find the derivative and they set it equal to 0. And then they go through and do some trig, isolating the trig functions. They find the values in which, in this case, cosine of x equals minus 1/2. And that's going to happen, and they talk about the quadrants, and if you remember from trig, all students take calculus, or there's various different ways to remember this. All the functions are positive in the first quadrant. Only sine and its reciprocal is positive in the second. Tangent and cotangent, and then cosine and secant are positive in the fourth quadrant. So cosine being negative here, we're looking at the second and third quadrant, and that's what we get here, quadrant 2 and quadrant 3. And we're going to have a reference angle of pi over 3. So if we have a reference angle of pi over 3 here, it means we're pi over 3 short of pi. Right, so this would be what would we get? 2 pi over 3? 2 pi over 3, because if I add a pi over 3, we'd have 3 pi over 3 and be at pi. So this reference angle would be pi over 3. So this larger angle here would be 2 pi over 3. Right? So this, I'm going to go back and say. And then if we look at this next angle here, we're going to be pi over 3 greater than pi, so 4 pi over 3. So this would be 4 pi over 3. And that is what this is saying here. So this would be our reference angles between 0 and 2 pi. We're going to have 2 pi over 3 or 4 pi over 3. And then the period is going to repeat itself every 2 pi. And that's kind of what they're saying here, any full rotation of the unit circle of 2 pi. So I can write this as 2 pi over 3 plus 2k pi, or 4 pi over 3 plus 2k pi. So it turns out there are going to be 2 instances which cosine of x is minus 1/2. That's going to happen in the second quadrant and the third quadrant. But then it's also going to happen every time I rotate, or every time I go through that unit circle, by adding 2 pi to any of these two angles. So that's kind of what this is going through, and you might remember a lot of that from trig. So in this problem above, you're going to go take the derivative, set that equal to 0, and then solve for the quadrants which satisfy that. And then all of this is going to have probably 2k pi, because the period is going to end up being 2 pi. Now if this x was something different, if this was cosine of 2x or something, that would change the period. So that's possible where then you would have something like k pi as your period, if this cosine was like of 2x. So hopefully that kind of clears what's going on here. If you have any other questions, please let me know.